So the title of this module is The Nature of Meaning. And what we do here is I will give you some basic considerations about what people have said about linguistic meaning and the various approaches and the best way to look at various phenomena that have to do with linguistic meaning. Semantics is the subfield of linguistics that studies the meaning of a sentence or utterance, how meaning is constructed, what the building blocks are, what the rules and restrictions are on the possible combinations of the basic units of meaning. It uses a lot of tools that come from logic and mathematics, which is why it is often called formal semantics, as it uses the formalism of logical formulas. This formalization allows the construction of very precise interpretations for sentences, but it also makes it difficult to follow a semantic argument without being technically trained in the abstract logical formulas, in the abstract logical framework. In some later modules, we will look at some of the technical background that will be necessary for people who are following the course to understand the material as we go along in the course. Now, what's the meaning of a sentence? If the meaning of a sentence or a word is more words or sentences that paraphrase or define what it means, say a dictionary entry, it eventually becomes circular because we are using more pieces of language to establish the meaning of one piece of language. If meanings aren't more words, may they be concepts or ideas in the mind. For example, say the meaning of the word monkey is the concept monkey that a person forms and associates with the word. Then every word has a concept associated with it. This is a position that comes, for example, has been considered by philosophers like Fodor in his work, Fodor 1975. But what about the concept associated with words like how and if? A big problem for meaning, for the idea that meanings are ideas or concepts is posed in the twin earth thought experiments. Refer to the philosopher Putnam, 1975. Also, how do we understand the concept monkey? The best way perhaps is to identify all the animals that fulfill this property. But if we are going to explain the concept monkey in terms of the animals which it encompasses, why not link the meaning of the word monkey directly to the set of animals? If this is true, that is, if word meaning is language external and mind external reality out there in the world to which a word can or cannot apply, then the meaning of a sentence are the conditions in the world under which the sentence is true. The knowledge of meaning is the knowledge of the conditions in which, under which a sentence is true. Okay, this is a position that you will find in the works of philosophers like Davidson, Lewis, and so on. This approach to semantics is sometimes called the truth conditional semantics or model theoretic semantics. Model theoretic semantics is one variant of truth conditional semantics. And the central idea here is that knowing the meaning of a sentence is knowing its truth conditions. And this is common to other variants like possible world semantics, situation semantics, and so on. The meaning of a sentence is technically called a proposition, or more formally, the denotation of a sentence is a proposition. In truth conditional semantics, the proposition expressed by a sentence is simply its truth conditions. In possible world semantics, the proposition is a set of possible worlds in which the sentence is true. Just as the word monkey denotes the set of possible monkeys, a sentence denotes the set of possible worlds in which it is true. The truth conditional view of meaning is also a good way of understanding the meaning of logical words like and, if, and not. The truth conditional meaning of a sentence of the form P and Q is the one which satisfies the truth conditions of both P and Q. Meaning as truth conditions also gives us a handle on some intuitive semantic concepts like synonymy, entailment, and contradiction. Two sentences are synonymous if and only if they have the same truth conditions, the same set of possible worlds in which they are true. Two sentences are contrary if the set of conditions or worlds in which one is true are completely disjoint from the set of conditions or worlds in which the other is true. A sentence P entails another sentence Q if the set of worlds in which P is true is completely contained in the set of worlds in which Q is true. The tool of possible worlds becomes very useful in understanding modality and the semantics of words like must, can, may, necessary, and so on. The tool of possible, truth conditional semantics also gives us a handle on the semantics of various other logical words like all, some, the numeral words, and a whole bunch of expressions like this. Now, if the meaning of a sentence is its truth conditions, what are the truth conditions of an interrogative sentence like, what did you eat? What are the conditions under which it is true? Non-declarative sentences like these and imperatives require some extensions to the truth conditional view of meaning. A major approach to understanding the meaning of questions in truth conditional terms is in defining a question in terms of its possible answers. Okay. This follows a tradition about the semantics of questions that comes from Hamlin, Kartunen, and so on. We will look at some of these issues again in some of the forthcoming modules. Okay? On this view, the meaning of a question that can be taken to be the set of propositions that are possible answers to it. Now that we know that the meaning of a sentence is its truth conditions, how do we arrive at the meaning of a sentence from the meaning of its constituent words? This is the central goal and major preoccupation of formal semantics. In the rest of the module, we'll see some of the basic ways how meaning is put together from pieces. Let's look at what we call predicates and a phenomenon that we call saturation. Again, in this module, I will just give you an introduction to these concepts. We will deal with these notions in much more detail in some of the other forthcoming modules. So let us start with a two-word sentence like Kumbhakarna snores. We just saw above that the meaning of a word like monkey is the set of monkeys in the world. In the case of names, it would simply be the singleton set of a person referred to with that name. The referent of Kumbhakarna is the Rakshasa giant with a great appetite and the boon curse of sleeping half the year. But what is the meaning of snores? We can get the meaning of snores by subtraction, removing Kumbhakarna from the proposition. We already know the meaning of the proposition is a set of possible words in which Kumbhakarna snores. The meaning of snores would then be an incomplete proposition with the subject missing. Technically, a predicate and its subject, a predicate like snores, is an unsaturated proposition, also called a property. The relation between a predicate and its subject is called predication. The phrase that saturates a predicate is the argument. A predicate can be a verb like snores or an adjective like fat, as in the sentence Kumbhakarna is fat. The predicate in this sentence is be fat. Then what is the meaning of is here? It contributes the present tense and nothing else to the meaning of the sentence. The predicate can also be a noun like Rakshasa. In Kumbhakarna is a Rakshasa, technically a predicate nominal. What is the meaning of a here? The meaning of an indefinite article like a is quite complex, and we won't be dealing with it in this module. Later on we will see a particular variant, or at least one of the meanings the word a can be argued to have when we talk about the nature of quantification or quantified statements, and so on. A transitive verb like kill in Rama killed Kumbhakarna is a doubly unsaturated proposition which requires both the subject and the object to complete it, and is known as a relation. But which of the two arguments in the relation combine with it first? The order is important, and here syntactic structure gives us the answer. The verb and the object come together first. The principle of compositionality says that the meaning of a sentence is built only from the meaning of its constituent parts and nothing else. The way these parts are put together also contributes to the making of meaning. The subject is the agent who does something, here Rama, and the patient is the one to whom something is done, in this particular sentence, the patient being Kumbhakarna. These semantic categories are the thematic roles, along with others like locations, experiencers, and themes. These are all subatomic building blocks of meaning that are pieced together into the meaning of a lexical item, like a verb. Properties are formally modeled using functions, and the system to do that is called the Lambda Calculus. For example, the property denoted by snores is represented in the Lambda Calculus thus: lambda x, full stop, x snores. A single letter called the variable indicates the place where the proposition is unsaturated. The lambda and the associated variable, here x, announce that this formula indicates a function and that the variable is the argument of the function. So the property is fat and the property is loyal are represented by the formulas lambda x, x is fat, lambda x, x is loyal. The two-place predicate or relation killed is represented by a formula with two lambdas at the beginning announcing its doubly unsaturated nature. The first variable corresponds to the first argument that is saturated, the object. The second variable represents the second argument, the subject. So we can write this as lambda x, lambda y, such that y killed x. The lambda calculus representation of Kumbhakarna snores through function application is the function lambda x, x snores, applies to Kumbhakarna, gives us the proposition that Kumbhakarna snores. Another basic semantic relation beside predicate saturation is that of modification. In the sentence, Kumbhakarna is a loyal Rakshasa, the phrase loyal Rakshasa is a complex predicate formed from the two simpler predicates loyal and Rakshasa that we saw earlier. How do the two properties come together to form another predicate? Neither one can saturate the other. A completely new process of semantic combination called predicate modification is at work here. If you are interested in more detail about predicate modification, you can look up various semantics textbooks. For example, the textbook by Heim and Kratzer, 1998. You can also find various variants of this rule in other work in linguistics, for example, the work of the philosopher and linguist Jim Higginbotham, and so on. The precise technical implementation of this rule is beyond the scope of this module, but it derives the truth condition that Kumbhakarna is a loyal Rakshasa if and only if Kumbhakarna is loyal and Kumbhakarna is a Rakshasa. Basically, an intersection of the two properties loyal and Rakshasa. But not all modification is intersective. See Party 1986. Okay? We'll see some of this in more detail again in a later module. For example, the truth conditions for Kumbhakarna is a short Rakshasa is not the same as Kumbhakarna is short and Kumbhakarna is a Rakshasa. If Kumbhakarna is 10 feet tall and the average height for Rakshasas is 15 feet, he is a short Rakshasa. But Kumbhakarna is tall by human standards. So what counts as short depends on the context or the comparison class. When short is combined with Rakshasa, the comparison is restricted to only other Rakshasa. In intersective modification, on the other hand, the comparison is with any relevant set, not just Rakshasas, as in the sentence Kumbhakarna is short. These kinds of modifiers are called subsective or vague and are treated not as simple predicates but as higher order predicates, which can only be saturated by another predicate. By itself, the meaning of these predicates can't function as the main predicate of a sentence and can only be saturated by a property, not an individual or entity. So short takes a property P and then means shorter than the average P. So short Rakshasa is a function that takes an entity X and returns true if and only if X is a Rakshasa and X is below the average height for a Rakshasa. Relative clauses can function as modifiers just like intersective adjectives. For example, Kumbhakarna is a Rakshasa that Rama killed has the same derivation as an adjective plus noun combination, with the two predicates in this case being Rakshasa and that Rama killed. Another set of modifiers are adverbs. So if I say Kumbhakarna snored loudly, the meaning contributed by loudly is that Kumbhakarna's snore was loud. Kumbhakarna's snore is the event described by the verb snore. Many linguists and philosophers, following the work of the philosopher Davidson, now think that the meaning of a verb like snore or kill in terms of one place or two place predicates is not enough, and more decomposition of the meaning into thematic roles like agent, patient, and an event of snoring or killing are warranted. So in terms of events, the meaning of our sentence is that there was an event of snoring, Kumbhakarna is its agent, and that event was a loud event. The suffix li attaches to the adjective loud, which modifies nouns and turns it into an adverb, which modifies events. The composition is exactly parallel to the intersective adjective case we saw above. There was an event of snoring and the event was loud. Manner adverbs like loudly and locatives and temporals like in the bed and last night, which describe the place and time of an event, are composed this way. But again, not all adverbs can be treated as intersective. For example, in Kumbhakarna snored intentionally, the event of snoring is not merely intentional. It is intentional only on Kumbhakarna's part, not on anybody else's. For example, if Ravana intended for Kumbhakarna to snore, but Kumbhakarna himself didn't, this sentence can't be true. For these adverbs, we need the more complex perspective on adjectives as higher order predicates. Intentionally is saturated by a property P, and they together form a complex property which describes an individual X if X did P intentionally. Here, intentionally combines with the predicate snored, and this complex property describes an individual who snored intentionally. Another class of expressions in language are quantifiers. We have seen noun phrases which refer to sets of entities like monkey and those that refer to an individual like Kumbhakarna. But not all noun phrases are referential. For example, nobody. Phrases like every Rakshasa, many Rakshasas, some Rakshasa, and no Rakshasa are called quantifiers as they express the quantity of some noun. A quantifier has a determiner like every, some, many, no, and a restriction, a noun phrase like Rakshasas. To understand the meaning of quantifiers, let's take a sentence like every Rakshasa snores. We already know two modes of semantic composition, predicate saturation and predicate modification. We also know that Snores is a property and Rakshasa is a property. Compositionality tells us that the meaning of every combines with that of Rakshasa, and this then combines with the meaning of Snores based on the syntactic structure, every Rakshasa one unit, which then combines with Snores. So every Rakshasa must saturate its Snores or vice versa. But only individuals can saturate a predicate, and every Rakshasa does not refer to an individual. Later on, we will see further arguments why they cannot refer to individuals. So it must be that the meaning of Snores saturates that of every Rakshasa. That means the quantifier is saturated by a property giving rise to a complete proposition. In other words, the quantifier is a predicate that takes a predicate and returns a proposition, reversing the usual mechanism of saturation. A quantifier is a second-order property, a property of properties. Here, every Rakshasa tells us that the property it combines with describes all of the Rakshasas. The determiner every combines with a noun such that it describes a property P if P is true of all the n's. N is an argument of every and saturates the incomplete quantifier represented by the determiner, which is then saturated by the property P. So the quantifier determiner is doubly unsaturated, just like a transitive verb. But unlike a transitive verb which combines with two individuals to form a complete proposition, the quantifier determiner combines with two properties to form a proposition. The determiner every here tells us that the Rakshasa property describes a subset of the entities described by the Snores property. Other determiners can be understood in a similar way. Some means that the noun property argument and its predicate property argument overlap such that at least one entity is described by both. No means that the noun property and the predicate property don't overlap at all. Most says that the predicate property describes more than half of the noun property. An extension of this intuition between quantifiers to all noun phrases, including names for the sake of a uniform semantics, is called generalized quantifier theory. Later on in the course, we will see two modules that deal with generalized quantifier theory. So we will see generalized quantifier theory again in much more detail. Generalized quantifier theory also allows for the conjunction of a quantifier and a referring noun phrase in a sentence like Kumbhakarna and every monkey snores, because only two phrases of the same syntactic and semantic type can be joined. A last class of lexical items whose semantic investigation has concerned many linguistic semanticists over a long period of time is the class of lexical items that are called negative polarity items. Negative polarity items, called NPIs for short, illustrate a deep logical property that natural language is sensitive to and some crucial evidence for linguistic theory. In understanding NPIs, the two main questions are what kind of sentences or environments allow or license NPIs? What do they have in common? Why do NPIs require a licensor of this kind? What is it about NPIs that needs these environments? NPIs have been described to like to live in the shade of negation. For example, the English word ever and the English word any occur in sentences like Kumbhakarna won't ever wake up and Kumbhakarna doesn't have any friends, but not in sentences like the ungrammatical Kumbhakarna will ever wake up and the ungrammatical Kumbhakarna has. But NPIs can also occur in some not obviously negative contexts like questions, conditionals, and some quantifiers, but not others. Will Kumbhakarna ever wake up? Does Kumbhakarna have any friends? If Kumbhakarna ever wakes up, I will feed him. If Kumbhakarna has any friends, they should wake him up. Every Rakshasa that has ever tried to wake Kumbhakarna up has failed. Every Rakshasa that has any friends does not snore. On the other, you can contrast this with the ungrammatical some Rakshasa that has ever tried to wake Kumbhakarna up has failed, or the ungrammatical some Rakshasa that has any friends does not snore. Klima, one of the earliest proponents of a theory of NPIs, proposed that they must be in construction with a trigger that is either overt or overt negation, or what he called an affective elements. This did not have much explanatory power besides incorporating the descriptive generalization into a syntactic licensing analysis. Fauconnier 1975-1978 and Lagisson 1979 approached the matter from a semantic angle and noted that NPI licensing contexts share a subtle and deep logical property that Lagisson called downward entailment, which we abbreviate as DE. To understand DE, we take a word which expresses a property and compare it with others that express a subproperty, a hyponym, or a superproperty, a hypernym. For example, carrot expresses a subproperty of vegetable. Food is a superproperty of vegetable. A simple non-negative, non-quantified declarative sentence allows inferences from properties to superproperty. This is called upward entailment, or UE. So, Kumbhakarna ate a carrot entails that Kumbhakarna ate a vegetable. The logical feature of not, the most basic property of licensors, is that it reverses this inference pattern, creating entailments from properties to subproperties. This is DE, or downward entailingness, or the property of being downward monotone. So here we can see that Kumbhakarna did not eat a vegetable entails that Kumbhakarna did not eat a carrot. If we take a sentence with a quantifier of the form determiner, restriction, predicate and check where an NPI can occur with this structure, we get the following pattern. In every good sentence where NPIs are licensed, the NPI, the negative polarity items like any and ever, are in a context that license that is a downward entailing environment. So, for example, every Rakshasa that has ever tried to wake up Kumbhakarna up has failed. No Rakshasa that has ever tried to wake Kumbhakarna up has failed. Contrast that with examples that are bad with NPI in the restrictions. So, some Rakshasa, 3 Rakshasas, the relevant sentences are bad. Now you can check the downward entailingness of these constructions, and you will find that these are precisely the environments that are DE.